Hello students, in previous lecture we have talked about the cluster points, accumulation point or limit points and isolated points. And we have studied some examples for finding derived sets in RU. So with help of that you can also find derived sets of any subset of any metric space. In this lecture we are going to study one result about the closed set with help of derived set. So take the theorem, or we will study theorem now. Let XD be a metric space, and A be subset of X. Then A is closed in X if and only if, then A is closed in X if and only if A dash is contained in A. A dash is contained in A. Okay. So proof. Firstly, we'll prove necessary condition. If A is closed, okay, necessary condition. Suppose A is closed subset of X. A is closed subset of X. What is your aim? We have to show that A dash is contained in A. Let X belongs to A dash. We'll take X belongs to A dash. This implies open sphere about X doesn't contain any point of A other than X. This must be contain at least one point of A for every r greater than 0. Every open sphere about X contain at least one point of A other than X. Give one for it. Okay. Now since A is a closed set, implies A complement is open. A complement is open set. Therefore, for X belongs to A complement, there exists some R1 greater than 0 so that SR1 X is contained in A complement. SR1X is contained in A complement. This implies SR1X intersection A must be equal to phi. Right? And therefore SR1X minus X intersection A is also phi. Implies X is not cluster point of A, or implies X doesn't belongs to A dash for any X belongs to A complement. For any X belongs to A complement. X is not in A dash. Is it right? Okay. Now if, what is our aim? X belongs to A dash. Now if X doesn't belongs to A dash, A, then x belongs to A complement. X belongs to A complement. Therefore, for x belongs to A complement, this solved. Is it right? This is contradiction to x belongs to A dash. This is contradiction to x belongs to A dash. Therefore, our assumption x doesn't belongs to A. Sorry. Therefore, our assumption x doesn't belongs to A is wrong. Therefore, x belongs to A for every x belongs to A dash. This implies A dash is contained in A. A dash is contained in A. Now, sufficient condition. We'll prove sufficient condition. So suppose A is subset of x. A is subset of x such that A dash is contained in A. What is our aim? A is closed. A is closed set. Okay. That is to show A complement is open. A complement is open. So we'll take some point x in A complement. So let x belongs to A complement. Implies x doesn't belongs to A. Okay. Implies x doesn't belongs to A. Implies x doesn't belongs to A dash. Since A dash is subset of A. As x is not in A, therefore it is not in A dash also. Since x doesn't belongs to A dash, x is not in A dash, what this implies is SRX minus x intersection A is phi for some r greater than 0. For some r greater than 0. Okay. So SRX doesn't contain any point of A. SRX doesn't contain any point of A. Is it clear? Implies SRX intersection A is also phi as x is not in A. Therefore, SRX must lies in A complement. Implies SRX is subset of A complement. Thus, for any x belongs to A complement, there exists r greater than 0 such that SRX is contained in A complement. And therefore, A complement is open set. A complement is open set and therefore A is closed set. A is closed set. So, with the discussion, we'll stop our today's session. Thanks. Bye bye.